Uh, Hello, I am Gerardo García Peña. My English is pretty limited, so if you don't understand me or something, please shout, "No te entiendo!" and I will try to pronounce better. Well, I will speak about ESIL. ESIL, please go to the next slide. ESIL is an intermediate language. It is based on available strings with a Polish-like order of evaluation. It is like all calculator, more or less, based on stack. It's the same like fourth language, if you know the fourth. It's used for building virtual machines. We'll see that pretty limited, but it is used for that. And it runs securely inside R2 with its own stack, instruction set, and registers. But the registers is not used like a space for operations. Registers are the registers of the machine, and some artificial registers that we will see later. But well, it is used in R2 for two purposes: describing the behavior of assembly instructions and do emulation. It is only found in R2. It is a specific technology of this platform. Please go. I took contact with ESIL last year in the r2con, in the previous r2con. Brainstorm explained how he reversed a quadcopter using R2 and how he used R2 for fixing one of the motors of this quadcopter. The quadcopter was using an REM CPU, but each motor has a tiny AVR CPU inside. So it started to fail in one motor. He captured the firmware and tried to fix it, but he found that the AVR emulator and the AVR analysis tools were pretty buggy, and they needed some fixing. So I take this challenge, and I take the knowledge that give me a squatter about the null style, and then I rewrote the VR analysis plugin. After this little adventure, I observed a lot of limitations and some problems that has ESIL, and I will comment these problems in these slides because, in one hand, to have a revenge about the pain it was, and in other hand, to gather all these limitations in one point for later maybe improving the ESIL emulation, because I think it's pretty powerful and it will be really useful tool for reversing things. So please go to the next slide. But first of all, if you are thinking that QEMU is a better solution or another emulator, maybe, but it's not so great. I think that ESIL is great because it is very simple. It allows to easily write small emulators, and the performance is not the goal of these emulators, giving a high degree of flexibility that you can find in other emulators like QEMU, MAME, or whatever you want, VirtualBox. So the objective is not to put a Windows system, reversing while you are playing a PC4 game, etc., etc. It's very limited, but I think that it should not be so limited. I think that it should be able to emulate an Arduino platform or Commodore 64 or these types of platforms, especially for embedded hardware. A lot of time you want to reverse some piece of code, you want to run it, and if you go to a complete emulator and you have a special hardware handmade and you want to include some little hardware or some inputs, outputs, or simulate parts of the firmware, with a simple emulator is possible. With QEMU and these emulators, maybe it's more difficult. So go to the next slide. I will speak now where ESIL is used in the ESIL is a language used by analysis plugins called anal plugins, used to fit the ESIL virtual machine. Another plugin is a complement for a disassembler, the SAMS plugin. Usually, an architecture implements both plugins, but it's not mandatory. There are architectures without an anal plugin, and the users seem happy. I don't know why, it's a pity, but having an anal plugin is a very happy feature. If we go to the Radar code, please open. Oh, I will take a look first of all to the SAMS plugin. First of all, AMS ABL. This was not right. This was not right by me. This is a disassembler. If you go to see the code, it's basically a function, a main function. Todo bajo, solo aquí. Well, this is the description of the plugin. Here you describe the types of CPUs and go to this assembler. This function is called for each instruction in the disassembly routines of well, if you go to well, this is the real disassembly routines. If you take a look inside, you will see that it is basically an analyzer that goes to the memory, fetches instruction, decodes it, and it converts to string of the form opaques, one, etc., etc., etc. In this case, it's over here. We will find other types of instruction. But, joder, sí que hay cosas de volver. Well, you can see it's small, but if you go to the analysis plugin, this is a disassembler. You might think the analysis plugin will use all these things. I didn't know there was so much, but you might think that it's not a good idea to write. It's better to use this. Really not. In the analysis plugin, we found that all the task of decoding, of converting, is done again. This is because if you go open the capstone disassembler, for instance, will be easier. La puta. No, esto no. This is a pretty clear example. If you go to this assembler instruction, you will find that he opens a capstone, fetches the code, and goes to the capstone disassembler. Nobody knows what is happening inside, and it returns the fucking string. It's very easy. But if you go to the analysis of the same plugin, aquí anal x86, you will find that the same CC open is done again. The CC open and the operations of disassembling is done again. Why? Because the AMS plugins are not the path to get that disassembly. The design of Radar allows to have an anal separated completely from disassembler. This is good because it gives you a lot of flexibility. You can import code from any part and do anything you want, but there is not any type of coupling between them. This is good, but it is bad. Why it is bad? If we go to the slides, toma ya. We find that, the next slide, does not enforce the coupled design and plugins. An anal plugin usually needs more information than the rest of code design in forgive. This is because there is no common way of doing things in these parts. Why? The emulation needs different information than the disassembly, and the structs of the internal of Radar doesn't give this information. Anyway, it's not, the anal plugin does not receive an information of this part. If you want to use the AMS plugin you must call explicitly. You have to make the couple explicitly. So has these implications, the obvious. This might read on different information. In some cases, you disassemble some instruction in the interactive view, is the name of visual mode. Yeah, you disassemble some instruction visual mode, and when you check the ESIL code, does not do the same because they are decoding in different ways the same instruction. So a bug fix in these ARMs does not affect a bug fix in an AL, and the other side is the problem. This promotes also code redundancy. This is the first problem I see when I started working in this project. But well, this is some about architecture. And now this is an ESIL string. This is a very nice ESIL string. You can see that the coded instruction is subtracting 8 from the ARSP register in an Intel x64 platform. The operations in the ESIL strings are, we put 8 in the stack, the RCP register, and do the subtraction. Later, we update the CPU flags with some information that gives ESIL for after a mathematical operation, the overflow flag, the signal flag, the stereo flag, etc. Okay, it's pretty clear. The problem is that it's not always it's not the same in other architectures. The problem with other architectures is that this information cannot be recycled, and ESIL is pretty complex language, maybe. It's obvious that it's very easy to read if you are math. I wrote that a lot of times. That's the reason I don't speak well English. I don't speak Spanish well also. I don't speak a lot of time. It's better. But well, this is the same thing. I have put it in parts, and now I will explain during the next 2 hours the contents of this string. No, don't worry, it's a joke. But this is the problem. The problem of ESIL is a good language for describing instructions, but not for describing for humans. Maybe the original idea of ESIL was to describe instructions in this way for making like a manual of each instruction. You can see that and you say, yes, I can understand what it's doing the sub instruction, but if you see that, you don't understand nothing, sorry. So ESIL is maybe a good language, but not for humans. It's a two-level language. It's good for emulating code, but not for describing them. The reason is that ESIL was designed with Intel x86 assembly in mind. That doesn't matter. The problem is that it's not good. But ESIL, as you have seen, it only speaks about instructions, not only describes instructions, but does not describe the CPU internal state. Why? Because it is code for being executed. Was written like, for this objective, and we have observed that there are a lot of instructions, especially in EOBR, that update the internal state of the CPU, but in registers that are not saying by the programmer. There are a lot of registers in a CPU that are hidden. For instance, the EIP register in x86 cannot be accessed directly. You have to push and pop, but it's not reliable but mop instructions, etc., etc. Is it an internal register? Well, not very internal, but there are other registers very internal. Timers, counters, etc., etc., that must be accessed with special instructions, and they exist, but they are not viewable directly or doesn't exist for programmers. So, where we store all this information? Well, now in ESIL it's not easy. You have to invent these registers, especially if they are not documented by the CPU, and add them into the profile register, in the register profile. The register profile is a meta language maybe or something like that that only exists in plugins. Well, what's happening? Yes, no está arriba, está aquí, Qué complicado que eres. Bueno, this is a register profile. It is like a description language. You declare, this is over here. Ah, yes. Over here. This is well, there are a lot of registers. There are some registers that I have added that are not accessible to us, like RAM-X, RAM-P. These registers, for instance, in EVR, exist in some CPUs, but not directly accessible by programmers. There are some registers that I have invented, like proc, RAM, ELS, RAM, that are used for registering all the CPU internal state. The problem of adding this information in this part of the program is that this part of the program is visible to the r2 user. Sorry, radaderos. Radaderos means r2 or radade2. I will say radaderos all that speed or that. Sorry, the problem adding the information here is that you are adding information visible to the r2 user, and it is very confusing because they are maybe there are some registers that they are alias, or registers are very special. This register in EVR exists inside the CPU, but it's never accessible from the programmer. This is a special address in memory. It is a hack for having the key in here. Well, there are a lot of things here that shouldn't be visible. The register profile. I have shown this because it's the only CPU state that you have for ESIL. It's the variables or registers published to the ESIL virtual machine. I think it's a problem because an emulator needs more than this, especially because there are a lot of versions of the same CPU and not all the CPUs have the same registers. So if we want to emulate a real CPU, it's not enough storing the public registers. We must manage a lot of internal information, I have said, not known or documented. We have to include some configuration options, like this for this type of CPU, flags of the CPU. I mean flags, not flags, programmable flags. I mean internal flags when the fabricador, ¿qué fabrica? The CPU manufacturer changes a lot of CPUs before they go to the public. They configure CPUs for giving more or less functionalities, like in Power, IBM Power. Well, what if we want to do more complex things? How we can store this in CPU information? It is a limitation that we have now. How we can reconfigure the register profile on runtime? Because you start Radare and you say, I want to go to IVR, I want to go to this model or this model. We need to change this, and it's not possible in this moment. If you try to change the register profile on runtime, it crashes. So, yeah, lo probé y mal. Me fue muy mal. Bueno, or those certain things when a register fails. Bueno, there are those hooks inside that you can use to make hooks on register changes, etc. But I think they are not enough. They should be written on a higher level language or intermediate language for making this platform more flexible, more well. Also, another problem we have found in ESIL is that the address space is only one. There's only one address space. ESIL was thought as a mechanism for emulating small pieces of code, so does not emulate a real computer address space. The address space in R2 or R2 by default is the address space defined during the binary load. If you go to array, you put R2 space bar bin bar ls, enter. ls, the ls binary is loaded in an address 0 and then mapped to the RAM, and this is the address space. You can move this binary in the memory, yes, but it's not enough. When you start to emulate something, you have to build a real address space with its table, interrupt table, with parts of RAM, with part of video, etc., etc., etc. So now it's very difficult to emulate a real address space without changing the address space of Radar. Is one problem. Another problem is that some CPUs have several address spaces. I will tell this in another slide. And one big problem is that if you open a binary with these flags, the W flag, this flag, you open a binary with this flag and run ESIL code, and this ESIL code write on the binary, you will write a change on your own binary, so it's dangerous in this moment. Well, and as I said, an upload cannot manage or create new existing address spaces. I mean that if you want to add memory or move a binary to a certain location, etc., 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 you have to do this with those commands, and it is not very easy for a beginner. So the problems I have seen is that some arch like AVR needs some different address spaces. AVR have an address space for code, an address space for RAM, and the RAM address space have mapped a lot of sub address spaces, or have another special address space for an EEPROM. So it has 3 address spaces, I think. Maybe I'm correct now. I have written this quickly, but I remember that there was 3 address spaces. This is a party. It's very difficult to manage, and all this is hard code into the ESIL commands. You can remember the easy to understand ESIL commands. Hard coding all this logic, I mean these points, in ESIL maybe it's not a very good idea. So I think that ESIL have there a big limitation. In other architectures, the problem is even worse, and you may need to write a complete hardware emulator for the RAM managing, like x86 or x86 have a complete MMU that needs to know if it is in real space or protected mode, etc., etc., etc. So the ESIL virtual machine does not give any facility for this FreeA2S. One hard problem in ESIL in these moments are the section signals and interruptions, because it's a problem. Why is a problem? For me it's a problem because these 3 features are the first line of interaction with the real world of a CPU. There are a lot of input that comes from these signals. There are signals that comes from internal operations like bat instructions, legal addresses, division by 0, and there are signals that come from outside like sensors, DMA transfers, etc., etc., etc. The problem is that there is no any mechanisms in ESIL for launching signals and managing signals easily. This is an important need that needs to be introduced in the ESIL virtual machine. Also, if you think about it, I am the correct slide, yes. If you think about it, it is a bad idea to have all the logic of the hardware in the ESIL CPU emulator. I think that ESIL should have some mechanisms to add external plugins for emulating special hardware like video, tal, and these special plugins would need some mechanisms to give signals, extensions, etc. And finally, the I/O. A CPU without an I/O is stupid. Sooner or later, we want to receive data, write data. And I think this is the most interesting part of an ESIL emulator. Why? For instance, the hard disk, the laptop hard disk or any hard disk in the standard hard disk are running some CPUs. Most of them are running OVR CPUs, and they have a firmware, and they have an analog input, and they give a digital output to the computer and receive output, etc., etc. Some people have downloaded or extracted the firmware of the hard disk, and if they want to emulate code, they have to use special OVR emulators. Why? Because you cannot subministrate to the OVR emulator of the radaros. You cannot subministrate to the radaros, for instance, wafers, or recover the output of the firmware, and would be nice to run the firmware on R2 and emulate all the process of input-output of these devices. Why? They are very strange firmwares. You get the firmware of a hard disk, they are very specific, they do strange things. You don't know what are they receiving or what they are returning to the hard disk layer, I mean. So, capturing the data of a hard disk, loading to the R2 emulator, and obtaining the output of these routines will be useful for reversing this type of hardware that are very tricky. So, I think that it's a problem. There's no I/O, and I think that the minimum that we should support, we will see WAV files or digital files, I mean 1 zeros. Would be nice to also support virtual frame buffers for graphics and so on, but well, you know. So this is a short talk. My English is very good, so I prefer to do a short talk for the mental illness of all. So I have posted some comments and problems. I have put them together in this PPTX of Microsoft. Wow. I know that this is not enough for improving ESIL emulator, but at least I have made a critical review. In the future, I will try to make a positive action improving this. But I think the important is to gather all the limitations in the first step for writing useful code and not rewriting not so much useful code. So I think the next step will be make a roadmap for improving ESIL, defining some path of action for writing a better virtual machine or making a transpiler or compiler, or you want to say. But well, I don't have too much time, but I will try to do all my best. So I will be glad. So I will be glad to hear any question, opinion, proposal, anal proposal. Oh, no sé, pero tantos ordenadores que me confundo. Y no, bye. Greetings to Brainstorm. Greetings to Squatter. Y eso, que se inventaron todo el rollo anal. Thanks. If you have any question, I will try to...
Any question? Yeah.
Or you want to contribute to my...
Well, I have some comments that I would like to explain about some of the highlights that you have explained in the talk. One of them is that the I/O layer should be able to do all the things that you need. The thing is that it's the branch that we merged 2 weeks ago. But the problem is that this is not yet accessible from ESIL, so we should implement some special ESIL instructions to change different modes, like for example switching banks, which is also needed for Game Boy emulation.
Yeah.
This is something that it's possible with CL, which is the I/O branch that have been merged. But yeah, there is some more work on this, so if you want to...
No, I want to meterme ahí a saco. I want to emulate a Commodore 64, is one of my objectives, and I also need bank switch for emulating a 64.
There are things that changing register profiles, it's possible to do it passively and actively, so the analysis plugin can call a set register profile, and it's also able to change the analysis library can also...
I have to confess that I tried that only one time, and a lot of time ago, 1 year ago, and I crashed it. Maybe it was a bug of me, but maybe it was a limitation on this time.
In a year, many things changing. So maybe you should try again.
Yeah, I know that you call it Radade 2, but it should be Radade 20 over 9000 or like
the other thing is that the merge of analysis and disassembly plugins will happen sooner or later. The reason for having splitted things is that there are so many libraries that just implement like disassembly for random architectures, and having like just spending like 20 minutes for supporting an architecture is not the same thing as implementing the full analysis plugin to get the full instruction set.
Really, the first slide when I exposed the disacoupling between the ASM and analog plugins, it was a critique from the point of view of maturity. I mean, when you start a project and you need to add a lot of features, you like to have a lot of flexibility. You use a couple things to import and add external libraries like custom and such. And if you are starting a complete disassembler, it's very difficult to have a complete knowledge of all platforms in the world. So making a mega structure for supporting all the casuistics of all CPUs of the world is impossible. It's condemned to the fracaso. No sé cómo se dice. It's condemned to a fail. Why? Because it's impossible. You cannot have all this knowledge from the first step. But now I think that with the time and effort for coupling these more plugins is convenient. But I understand that it was an initial design decision taken for giving flexibility, what you have said. Yeah. sorry.
So the thing about register profiles is that having access to internal CPU registers is nice, mainly because you can change like the key or things like that, but maybe you want to hide them for... So maybe we should add a flag in the register profile to specify that some registers are internal, and when you are displaying the register contents, you will be able to choose if you want to show the internals or only the ones that the application is exposing them. But the register profile is mainly exposing what the kernel gives to the user when you are getting the register states, and usually that's more than the one that you get from userland, for example. So it's...
Yeah, it should be flags, what you have seen, some flags.
So maybe having like, maybe prefixing the registers with a dot to specify that they are hidden or something like that will be,
I have thought of a language.
Yeah, we can discuss more things.
Yes.
And the last thing that I would like to say is that exceptions and division by zero and an issue in the NMU that you are trying to read memory that it's not allocated or things like that, it should be possible. I mean, it was implemented some months ago.
Yeah, you can implement this, but you are forced to implement this on each ESIL instruction. You have to have a prefix on each instruction. I have received an illegal division by zero. Oh, but this instruction now have to jump to the interrupt
but this is implemented in a callback and in the simulator, so you can just say that when a specific event happens, you can handle that. So
you can handle, change the IP, etc. But
yes.
I think it is not a good idea because it puts a lot of logic in the C part, and I think that the ESIL part must be most powerful, not so much logic in the C part because the C is very difficult to change. And maybe an intermediate language for writing the CPU will be nicer because now it's very difficult. I tried to do that in the VR emulator, but it was very difficult. using callbacks.
Yeah, and about
Sorry,
signals,
sorry.
screens, and all this stuff, yeah, it's obvious that we need so many kind of events, like managing a single bit buffer stream, or checksumming stuff, or having a screen, or a speaker, or analog inputs, and events that you want to, if you are emulating like a microcontroller, you need to specify all these kind of things.
Yeah.
So that's something that we should think about, and that's something that changes the state of the SIL.
Exactly. Like fluid, yeah.
Yeah, so those are my comments.
So,
Thanks
no,
for your
thank
talk.
you.
If you have any question.
Sí, of course. No, me vengo cerquita para pegarte.
My question is not about the VM, but more about the syntax of ESIL, ESIL or as well. I'm planning to use it maybe for binary translation, so do you have any plan or you to make it a non so beautiful syntax and change it into 3 address codes or single static statement?
You want to answer, or
Yeah, there is one function that takes an ESIL expression and converts it into a Rail expression. So you have a disassembly with like instruction and then different parameters.
3 address codes or SSA?
Sorry?
SSA, 3 address codes.
SSA.
SSA. Thanks.
Yes.
I will go to show the translation of instructions. If we go to P? No. V? Visual mode?
If you go into visual mode,
eso.
then you can see the ESIL expression.
This, for instance, it's very easy, really. And if you plan to do a code analysis with an agnostic point of view, I mean, without thinking about the real architecture, this is very useful. You have here a stack virtual machine. And these are trees. They are very easy to analyze and to get information from that. And even you can use this translation for do optimizations. So now in modern compilers they're working with registers, but in all compilers they use stack machines. And really, so if you want to do code analysis with this, you have a lot of things. The problem is that when you are writing instructions, maybe some facilities to write these instructions will be nice, like intermediate language, like Lua, Perl.
Actually, this is the reason. I'm writing a transpiler right now, and I use the LLVM bytecode, and I would like to support other things. And if I don't have to write the backend for that thing, it will be awesome for me.
Yeah, maybe if you are analyzing LLVM code or no? No, yes, but so you have seen that it's pretty complex. Maybe this is more simple.
It's horrible.
Yeah, so I know that modern compilers are working with things like LLVM, but they are for very specialized performance reasons. For analysis of code, I think that the ESIL is better. It's more easier from my perspective. Anyway,
So,
one do with his ass what he wants.
So here is what I said. So you have the ESIL expression, and if you use the AOR command, you will translate. You will get the Rail representation of the instruction. Now switch off the microphone.
Is it Rail? Yeah, Rail.
Yes.
Okay.
R-E-I-L.
Yeah, but it doesn't support many CPUs, right?
What do you mean?
I mean, this is your own Rail implementation and translation.
This is a translation from ESIL.
Open
so
Rail.
all the architectures in Radar2 that are supported by ESIL also support Rail.
Okay. Thank you.
And you can get a list of these here. So all these architectures support the ESIL emulation. You can check this mainly with the E. So if there is this letter in there, it means emulation, so all ESIL. So you get support for all these architectures. Any other question? Thanks.
Gracias. any other question, my mail is here. And thanks everybody for your patience. Thank you.